Hi there, everyone. How's it going? This is some of your practice final exam open-ended questions that I'm going to walk through. Again, I'm going to go through them a little bit quickly, but you can always slow down the speed on the YouTube video or pause or go back and rewind and watch how I go through things. But again, to try to save time, I'll see if I can go a little quicker, but I want to make sure I go and explain everything step by step for you. So um, yeah, here we go. So first question is 41. And we have Bill lifts 1,000 Newton barbell 1.5 meters in 1 second, while Bob lifts 1,400 Newton barbell 2 meters in 2 seconds. So whose lift is more powerful? So first thing I'm going to do, I'm going to look at this and I see, okay, oh, it's looking for power, right? So I know right away I can get my power equation, which is power equals the work done over some given time. Okay, so that's kind of the most straightforward version of the power equation. Um, but it doesn't tell me anywhere here where I've done work. It doesn't say Bill has done this amount of work or Bob has done this amount of work. So what I need to do is actually also recruit my work equation, which is, force times distance cos theta, or some derivation of that. Okay. So the other thing we can start doing now is we can say, okay, well, I got work. So let me just plug that into that equation. So it'll look something like this. So I'll get my power. So power equals work over time, which equals, again, just placing this into work, we can say is force distance cosine theta all over time still. We're still carrying that over. And I can farther look at that and be like, okay, well, in the scenario that's been given to me, I know a barbell just its displacement is upward. So if I displace this barbell perfectly vertical, I know the angle from there is or on the x-axis, it's just 180 essentially. So what that means is cos theta is going to be 1. So when you multiply anything by 1, it's just what it is. So what I'm going to do is continue it on, and I'm going to say force times distance over time, and that's my equation. So now that I get there, and the reason I've been working there is, again, as always, we want to collect our variables first. So I saw that I had some newtons and some distance. So I know that's a force and a distance, and here's my time, right? I also knew, so if I would have done this a bit sooner, I got my newtons, my meters, and my time. Okay, so that's time. So I know, again, having looked at this equation, I'm like, okay, force times distance. I have a force and a distance for both of these. I knew that I had the variables for my work. I didn't express that right at the start, but I knew this heading in. So here we are. So now we're just kind of at this like plug, play, and compare. So for Bill, we have our 1,000 newtons. Again, now we're just using this equation for both lifters. So we have 1,000 newtons. It's our force times our distance, 1.5 meters, all divided by 1 second. When we plug that into our calculator, sorry, we can say this a little more. So power for Bill equals that, our work over our time. Sorry, when we calculate that all out, we get 1,500 watts. So the tricky thing here is you just got to watch that work and watts doesn't get too confused with one another. Yeah, sorry. Just to help keep everything straight, right? Okay, so we'll do this for the next guy, lifter here. So we have our power for Bob. Make that in our subscript. Again, you can make your subscript whatever you want just to help yourself track along. Perhaps you want to use that with the W's. You know, you could say work or W, watts, you know, whatever helps you keep track of everything. Okay, right, so we're back for the power for Bob. We got 1,400 newtons. That's our force times our distance, which in this case apparently a little bit taller or lifted a little bit higher, maybe overhead. So that's for Bob. And this lift was for 2 seconds. So we divide whatever we have by 2 seconds. And what do we find out? Well, Bob only produced 1400 watts. So when we look back at the question, this is sometimes something that students miss, although haven't necessarily lost marks to this point for it often. But whose lift was more powerful? That's what the real question is. So to kind of finish it off, we could say P Bill is greater than P Bob. So we can say the lift, the power that Bill did was greater than Bob, or we can just show that those were the differences, okay? Great.